Good afternoon, everyone. It's Breakout Investors with Jane Erickson and Chris Sue. So why don't we jump right in, because sort of everyone knows the story.
Hey Mark, hi everybody. So this game, so we actually had a few minutes to kind of just do some background stuff. Ashley was suggesting that maybe just focus on the Incal acquisition, a little backstory on that, make sure you guys sort of understand where it fits. And then I'll open it up for a few questions. So, you know, everybody's heard our story. I've said it so many times. If you're new to it, air test is in semiconductor capital equipment test, where in a segment normally referred to as burn-in, but often cycling, stress. There's all sorts of different stabilization, subtle variances that all kind of look like a burn-in system, but they can matter. We won't get into that right now. We're caught in a handful of macro trends that have been playing out for years that seem to make, I feel, our story better and better over time, as it's more applicable. So, starting off in semiconductors, the world's growing from 600 billion to $1 trillion. We're going to put $400 billion worth of capacity in place over the next, 6-7 years, which is more than ever before. Semiconductors themselves are actually not getting more reliable between smaller geometries, larger die sizes, compound semiconductors as examples. There are actually more needs for reliability burn-in tests, which the segment we play in is taking devices that have been tested good, but then stressing them for some period of time to weed out the weak ones without damaging the good ones. And then like compound semiconductors just do not have the reliability and never will of what you see in silicon carbide. There's too many states for them to exist in. I've said this before. I think there's like 100 states silicon carbide can actually mix into structurally. Only one of them is semiconducting. So it's actually really hard to make the one state that works. Whereas silicon only has one natural state and it's a perfect crystal structure. So all you're really doing with silicon is trying not to screw it up. Whereas in silicon carbide, you kind of have to manipulate it to get it to behave in a specific way. Otherwise, it damages and it won't work. Optical devices, more and more, they all need an extended burn-in because they all have this weakness having to do with stabilization that you need to, during the manufacturing process, actually run them for an extended period of time to stabilize their outputs. More and more optical devices, gallium nitride, and other compound semiconductors. So there's things that are going on that are driving to more and more reliability requirements. And by the way, AI large processors are an example of that. The processors are getting bigger. Defect densities are not getting smaller enough to make up for it. So every AI processor has a burn-in process, just like every Intel and AMD processor is burnt in today. Right? But some of the dynamics having to do with the AI companies are all fabless. Unlike Intel and originally AMD, they designed their own systems for their own custom needs. And so their burn-in systems were highly evolved, sort of like the DRAM guys. But the AI, it's every man for themselves through TSMC, and there's not necessarily a standard platform because the burn-in requirements are different by every customer. The next thing is more and more devices are going into applications that need reliability, automotive, AI, large, very expensive applications, or mission critical or safety related. And then last thing is heterogeneous integration. More and more devices are being mixed together on, say, multi-chip module-based systems or chiplets, which require a level of burn-in at wafer level, which is good for us. Or things like power modules and all, there's more and more devices being put together in the same package. If you burn it at that level, the one die fails, it takes out 7 other good die. Okay, so these are the macro trends that are going on that we're playing into. Kind of at a very high level, we were looking at all things related to compound semiconductors, anything related to automotive and mission critical applications, memory. For lots of reasons, the power requirements are changing that provide us a new opportunity. And candidly, we started off the year saying we're all in on AI. We just got to figure out where. And not just because it's sexy, but because of the amount of spend that's going on and disruption that's there. In our investigations, we identified at least one opportunity we publicly announced, which is a wafer level burn-in application. But the other piece was just lots of information related to all the changes going on in package form, both to qualify the devices, but also production burn-in requirements. That's where Intel came in. Intel's a small competitor. We've known them forever. I actually knew them from my Verigy days because they were doing RMAs for me, kind of a bizarre thing. They still do some RMAs for Advantest. So the RMAs are just board returns. So they were just doing support little fiddly things. We never really saw a ton. They've been pretty tiny. But candidly, they kicked our butt on our ABTS platform. Their tester's better than ours. Their software is way better than ours. And customers had a much higher preference for them, particularly in the qualification area. We were more the production guys, but if you weren't doing production, you probably would go buy an Incal system. Okay. So I had conversations. I've kind of met them every February since I've been here. On this February, what I learned was that they were getting traction with the AI guys, and a good number of them, which I'm like surprised at. Like, wait a minute, you're pretty tiny. How is that working? And it's like, well, we have a better mousetrap. And so as I started to dig into it, unlike what was the market leader, which was MCC, a private company out of Minnesota, MCC was really struggling to do these AI processors because they use the same architecture that companies like we did with our ABTS, which is all the power supplies are back behind the firewall, and they're trying to remotely provide core power to these devices that had 400, 800 amps per device. And then there's just too much IR drop through that. And so they weren't able to effectively bring up the parts. Whereas Incal has a unique architecture with their Sonoma platform that where the power supplies are located right next to the devices out in the chamber with their own liquid cooled subsystems. So they just had a better device, and it turned out they were able to start bringing up these devices again through the OEMs, or I'm sorry, the OSATs. So all these guys are fabless. So those OSATs were all saying, well, this works, you should bring up your device on this one. So their selling was done through the supply chain, which makes sense because they're so small, they don't really have the infrastructure. But then they were running into things where people say, well, can I use this for production? How many of these can you build? And if you go and you look at their facility, not many. It's like, it's pretty tiny. And so I was telling Ashley, we're in our conference room here. It's like, this is as big as their final test areas. You could barely put 2 systems in here. And so if you come and you say, hey, I want to buy 10 of these, you're not feeling very good. So long story short, it's like, this is one of those sort of peanut butter and chocolate kind of stories. So it's like, their architecture and our infrastructure, okay, and our manufacturing capability. And it's funny that for me to beat my chest and say how big we are, because clearly we're tiny, but by contrast to them, we're above the bar. We're big enough and people buy into it. So as we went out and did our due diligence, the customers were leaning in very strongly. They like this. They like the thing. And I feel like AIR is a good balance between tiny enough so we can create customer intimacy and not break that, which they did really well, but large enough that we have cash, infrastructure, manufacturing capability, things that were pretty scary for people to actually think about using their products. And so it looks great. So we, announced the deal. We were really thrilled as they dug into it, their willingness and candidly desire to take stock is always a compliment that says, it's sort of the equivalent of an earnout. If they're like, I just want all cash, you'd be going, uh-oh, right? So I think we struck the right balance, and they're already benefiting from our stock increase. And obviously, as that story progresses out, we think that'll play out well for them as well. In fact, at the end, they were all kind of fighting over the stock. There was some little subtleties about how, with employees and ESOPs and stuff, there would have been sort of an allocation thing, and people, I'll take more stock, so that was a positive.
Mhm.
So, we'll eventually they'll move over here. Probably want to do manufacturing as fast as possible because just so it shows better. And we have the capability to do more. And my experience, the closest thing was when HP bought Versatest, a little flash memory company. As soon as we bought them, people came out of the woodwork because it was like, okay, a real company. I was never even going to consider you before. And we've already seen some of that. So we'll see. We're excited about it. It also, actually, now we're talking, it gives us a really good look. So when you can sit there and talk about, a handful plus companies that are doing AI, and you can understand what the real thing is, because people don't tell you their secrets. They're not going to. And so you get to see what the real power is, what the real requirements are, what the real digital test capabilities are, what their real capacity needs are. It's pretty cool. And so, there's an element that there's real revenue, there's real, there's real margin behind it, there's real opportunities, but there's also a great, firsthand look of, candidly, some of the companies that are driving the most discontinuity in the whole semiconductor space right now, which is all these, multi-chip module-based AI processors. So it's kind of exciting. So that's our story about Incal, and I can answer any questions from here.
Sure. A couple questions. You mentioned, I think, on the last call that you have a lot of the same supply chain built in. So are you able to, would you be able to ramp their systems in a similar way that you can sell, I guess, Fox XPs?
Yeah, exactly. Yeah, so there's actually 3 different main products. That's how we think about it, kind of small, medium, large power. Okay. Their small one, which they have a backlog, they have customers that are ordering it. It's just sort of low power, candidly, pretty commoditized, just better software that we could never compete with it on the ABTS. They have a mid power system that was very much like our ABTS. It was just better. Okay. And they're very high power, they're ultra high power systems. Sonoma, we never made anything like that, and no one else really has something like that. And so the latter two, Alberto did a really good job of changing the way they were built to be able to scale. So using much more outsourced subcontract manufacturing of assemblies and bringing them in-house. The first one still takes a lot of hours to build, but the latter two are, quite frankly, like, they're a little bit even more advanced than we are in terms of how fast they can actually build them. But it's interesting, like, we have multiple chamber suppliers. Their chambers for the Sonoma ultra high power and Tahoe are actually our chamber supplier.
Oh.
And it's funny because I knew that because I went and visited them several years ago, and on the line I see a Tahoe system, and I'm like, really? Because this is a huge secret to us. Nobody would know who they are. We've kept it to ourselves, and they've been our little jewel, kind of because of the cost and structure. It's funny because the product manager of Incal I hired several years ago. He was in cahoots trying to go acquire these guys with us. But John was the one who figured out who our vendor was and went to them to get their chambers built. So he admitted to that. So now we can just put multiple chambers in the same boxes and have them shipped over to us and stuff. So that's an example. And that's a big one. Actually, the chambers are really, like, there's a lot to it. It can take you 6 months to a year to bring up a new chamber supplier because there's a lot to it. So
when you say they're a competitor, that's strictly in the packaged part versus ABTS has nothing to do with wafer level.
That's correct. Yeah. And for all intents and purposes, there's, I guess, I don't think it's material because we haven't sold an ABTS in a while. You can see by the numbers, but I think we're pretty well done with that. So we'll focus all our energy and package part on the Incal platforms. And, we'll continue to support our ABTS fleet with parts and things like that, but I don't think we'll take any more orders. Yeah.
And I think on the AI Accelerator company, you mentioned that you have ongoing evaluations that you expect to kind of get wrapped up in the next 1 to 2 months. It sounds like maybe.
Yeah, over the next few months, we said at the time, which is a month ago. So yeah, something like that. Yeah, so that's hot and heavy right now. I was working on it this morning again. So as we go to the bring up, it's hard. I would have told, if you would have asked me a year ago, I would have thought there's no obvious path to wafer level burn-in for the AI processors. That was because we didn't know everything. Okay, there actually is a path there, but I was surprised at what we learned. And again, this is kind of where, I don't want to suggest we spent $21 million to just have access to the customers, right? But there's some of that. I mean, just knowing the action, because you look at the data sheet and you're like, oh, I could never test this part. And then you look at the test mode and you're like, well, there's no one ever talks about their test modes. This is true with flash memory, with DRAM, with everything. How you test it doesn't look anything like you would guess. And they don't tell you. Nobody's going to share that. And so how do you get that information? Then once you have it, you just hoard it. You don't tell anyone. And then no one else can figure it out either. So that's one of and we've already learned some things. So we'll see.
So it's a real advantage outside of their actual business in terms of
yeah. I mean, I don't want to point out that I might steal one of their package part customers and turn it to wafer, but that might work out. That may happen that way, or vice versa. Some of the wafer level guys we've talked to that are looking for a real company with capability for package part, we now can offer to them.
So you can kind of provide like the complete package to a customer to be able to provide on either side, whatever they want to do. And the specs better now.
Yeah. And by the way, one of the things that AEHR has done, which had its pros and cons, is that Fox Systems, there is no probe card company that can build a wafer pack. If they did, they'd be violating our IP anyhow. There is no tester company that makes something like that. And the prober guys hate us because we displace all these probers, right? So you have to buy all 3 pieces from us, which is great for us, but it's scary, right? Like, so as more and more people buy it and they get it, then the risk drops, right? The AI is similar. Like, it's really hard to test these devices. And traditional package part companies sell the tester, and then the solution is done by somebody else, the application and all, it won't work. So these guys do the applications and understand that really well. And so it's a turnkey thing from them. So it's believable with our model, same thing, at least on the very high power stuff. On the low power stuff, customers do their own burn-in boards and sockets, and they don't even ask anymore. But on the high end stuff, this is an area that we want to be able to be the turnkey guys for.
Hey, Gain, looking at your various categories of opportunity, clearly it all looks related to AI in one way, shape, or form. How would you, kind of, if you listed them in order of customer sense of urgency, like these guys really need burn-in soon or now versus, the ones that, maybe can drag their heels a little longer? What's the sense of urgency, in order of categories?
I think, let's see here. Like, people that are really, our wafer level AI guy is cheering us on more than we are. Like, please work, please figure out how to make this thing work. I'd say the other, in the initial meetings we had with the AI customers for Incal, they're like, please don't screw this up. Please, can you ship more faster? Just, we don't want to grind you on anything. Just, provide stability and do all the things that we would like, kind of thing. I think silicon carbide is kind of maybe even with the package part AI. The GaN guy is, has real production needs that are coming up. In particular, the one we talked about that is forecasting their first production systems from us.
You got the hammerhead.
Silicon photonics, the urgency was to prove capability.
Okay.
Right? And then now it feels like now the market needs to be proven. You know, like, okay, now you're there, you've checked the box, we know you can ship a lot of them. We're trying to figure out how big that market's gonna be. I don't even know if they understand it very well yet. Those customers, but it sure sounds like, could be as early as the spring, but certainly next year sometime. The NAND customers are like getting ready because it'll come back. And as it does, the higher power requirements are a problem for them in terms of burn-in times and capacity requirements. So being able to do higher power and more parallelism is a key thing. But NAND's like a treadmill. Is there ever a clear discontinuity, or it keeps growing and growing and growing? It feels like their platforms are running out of steam. And so, they want us to be ready in time. But, you know, sense of urgency from a time, like they're not, hey, ship me a bunch of systems in 3 months. It's, let's work through the year to prove the benchmark. Let's then define that system together to make sure it'll work, during the next year, and maybe the ramp is the following year. DRAM, I keep waiting for all of a sudden someone to wake up and realize they have to do wafer level burn-in. And they figured out the DFT modes to do that. So as we do the NAND benchmark, we're actually contemplating the DRAM requirements at the same time. We're going to implement a MEMS-based wafer pack. And what that actually does is give us geometries that would allow us to do DRAM as well. It's subtle, but it's, there's a couple of reasons why we're doing that, but I don't know that the DRAM guys are ready yet. But some of the same people we're talking to.
Well, are they still going to have to make structural changes to how they actually, build those chips?
100%. Yeah.
Yeah.
The one hint, Mark, that's interesting is the guys would never do DFT before. No, we don't do that. Okay. I'm looking at an HBM memory on a NVIDIA processor right now. Those through silicon via, that's 1,024 pin DRAM. Okay. They are not testing 1,024 pins. They're testing 50 pins. So they implemented for the first time ever a low pin count test mode on a DRAM. Now they just need to implement it down to like 8 pins, which is what they did with their NAND.
Okay.
And architecturally, it'll still work. Okay. It's 1 IO instead of, 1024 IO. And that would allow them to get their burn-in to a point. So I feel like they've now proven that they can do low pin count test modes. They just need to go lower.
Yep. And the sense of urgency on the HDD.
Oh yeah, sorry. No, I forgot. It's kind of fun having so many other things. They're ramping this year. We're thinking, we don't have the order yet, or at least we haven't announced it. But it would be for systems to happen in second half, which is what starts December.
Yep.
And up from there. I mean, this has been a long time coming. So that just feels imminent, I guess.
Yeah. No, it's been a real long time coming. I've been expecting the upgrade to Hammer for probably 7 years now.
I've never mentioned that word, by the way, but I get what you're saying.
My bad. Ashley?
I was gonna, I had the impression that silicon photonics was quite a ways off. Has whoever's working in the space, have they do they have a product that is sort of done and developed,
Well,
ready to go?
without name dropping per se, but I know that Intel talked about a product that's supposed to be shipping next spring.
Right.
Publicly.
Yeah.
But is it real? I don't know. I mean, what does that mean publicly, right? So, yeah, we would love, that'd be great if that took off.
Yeah.
That'd be great. So a lot of this stuff is, you kind of build these products, you make your bets, you pick your leaders to cuddle up to, and you hope they're successful. And right now I'm, constantly reminded how lucky we were to have been selected by ON because they're killing it. I mean, they're absolutely taking share from people and they're continuing to do it. And that announcement with VW is a big, big deal. And so, yeah, I mean, may not help us with diversification, but I'll take it too. So,
But also,
Yep.
once it sounds like with Intel, once you get into a customer and you've been working with them for years now in silicon photonics, that you can get into different applications
As well. I mean, there's definitely, this idea of wafer level burn-in as a real thing.
Mhm.
You have to understand that 5 years ago, it just wasn't. I mean, it was just us talking about it and nobody was buying into it. There was no examples of it in any kind of production volume. Yeah, we have a picture on the wall with Micronis. Like, okay, great. Micronis is this tiny little company. Now TDK bought them, but that was it. That was the only production wafer level burn-in system on the planet 10 years ago. Okay. And, maybe even 7, 8 years ago, I have to figure out when it was. I mean, when Intel and Apple pinched their nose and said, okay, I'm going to go for it with us and drop down payments with us on something that had never been proven, they were bold, right? Now it's like, lots of people assume it's okay and, it's certainly not commoditized, but the belief that it works is changing with big companies too. Like it's, when you think of the silicon carbide, onsemi is a wide ranging company, right? Obviously Intel has lots of different, it has several other applications, but you're talking about, it's real. We're still tiny. I mean, right? We're really tiny. But there's more and more opportunities, and I think all those trends are coming our way.
Well, speaking of Intel and just processors in general, it sounded like on the tail end of the call, Larry brought up something about semiconductors, or the processors being tested at wafer level. Do you see that in the future?
We'll see. I would have said no until recently with this AI processor. Now I understand how sophisticated the low pin count DFT modes can be.
Mhm.
And I'm excited. Let's make it work. Let's get an order under our belt. But it looks encouraging.
Neither Breakout Investors nor any of its affiliates makes any representation or warranty, express or implied, as the accuracy or completeness of the statements or any information presented by this podcast, and any liability, including in respect to direct, indirect, or consequential loss or damage, therefore is expressly disclaimed. The views on this podcast expressed are those of the speaker and not Breakout Investors. No one on this podcast is an investment advisor, and no one is providing investment advice. Before investing in any company stock, you must do your own research. Thank you for listening.